How to wipe free disk space in Linux? When a file is deleted, its contents may still be left in the file system, unless explicitly overwritten with something else. The wipe command can securely erase files, but does not seem to allow erasing free disk space not used by any files. What should I use to achieve this?
Warning: modern disk/SSD hardware and modern file systems may squirrel away data in places where you cannot delete them, so this process may still leave data on the disk. The only safe ways of wiping data are the @secureerase command, if implemented correctly, or physical destruction. Also see how can I reliably erase all information on a hard drive? You can use a suite of tools called Secure Delete. This has 4 tools. SRM, securely delete an existing file. SMEM, securely delete traces of a file from RAM. SFIL, wipe all the space marked as empty on your hard drive. SWAP, wipe all the data from your swap space. From the man page of SRM. SRM is designed to delete data on mediums in a secure manner which cannot be recovered by thieves, law enforcement or other threats. The wipe algorithm is based on the paper secure deletion of data from magnetic and solid-state memory presented at the 6th Usenix Security Symposium by Peter Gutmann, one of the leading civilian cryptographers. The secure data deletion process of SRM goes like this. One pass with 0 XFF. 5 random passes. /dev/urandom is used for a secure RNG if available. 27 passes with special values defined by Peter Gutmann. 5 random passes. /dev/urandom is used for a secure RNG if available. Rename the file to a random value. Truncate the file. As an additional measure of security, the file is opened in O_sync mode and after each pass and sync call is done. SRM writes 32K blocks for the purpose of speed, filling buffers of disk caches to force them to flush and overwriting old data which belonged to the file.
The quickest way, if you only need a single pass and just want to replace everything with zeros, is run from a directory on the file system you want to wipe. The sync command is a paranoia measure that ensures all data is written to disk. An intelligent cache manager might work out that it can cancel writes for any pending blocks when the file is unlinked. There will be a time during this operation when there will be no free space at all on the file system, which can be tens of seconds if the resulting file is large and fragmented, so it takes a while to delete. To reduce the time when free space is completely zero, this should be enough to stop someone reading the old file contents without an expensive forensic operation. For a slightly more secure, but slower, variant, replace /dev/0 with /dev/urandom. For more paranoia, run multiple steps with /dev/urandom. Though if you need that much effort, the shred utility from the coreutils package is the way to go. Note that in the above, the small file is shredded before creating the larger, so it can be removed as soon as the larger is complete instead of having to wait for it to be shredded, leaving the file system with zero free space for the time that takes. The shred process would take a long time over a large file, and unless you are trying to hide something from the NSA, isn't really necessary emo. All of the above should work on any file system. File size limits. As Dan Moulding points out in a comment below, this may have problems with file size limits on some file systems. For FAT32 it would definitely be a concern due to the 2 GB file limit. Most volumes are larger than this these days. 8 TB is the volume size limit here. You can work around this by piping the large cat/dev/0 output through split to generate multiple smaller files and adjust the shred and delete stages accordingly. With x2/3/4 it is less of a concern. With the default/common 4K block the file size limit is 2 TB, so you'd have to have a huge volume for this to be an issue. The maximum volume size under these conditions is 16 TB. With the, still experimental, BTRFS both the maximum file and volume sizes are a massive 69. Under NTFS the max file length is larger than max volume length in some cases even. Starting points for more info. This URL. This URL. This URL. Virtual devices. As mentioned in the comments recently, there are extra considerations for virtual devices. For sparsely allocated virtual disks, other methods such as those used by ZeroFree will be faster, though unlike CAT and DD this is not a standard tool that you can rely on being available in pretty much any Unix-alike OS. Be aware that zeroing a block on a sparse virtual device may not wipe the block on the underlying physical device. In fact, I would go as far to say that it is unlikely to. The virtual disk manager will just make the block as no longer used so it can be allocated to something else later. Even for fixed-size virtual devices, you may have no control of where the device lives physically, so it could be moved around its current location or onto a new set of physical disks at any time, and the most you can wipe is the current location, not any previous locations the block may have resided in the past. For the above problems on virtual devices, unless you control the hosts and can do a secure wipe of their unallocated space afterward, wiping the disks in the VM or moving the virtual device around, there is nothing you can do about this after the fact. The only recourse is to use full disk encryption from the start, so nothing unencrypted is ever written to the physical media in the first place. There may still be call for a free space wipe within the VM, of course. Note also that can make sparse virtual devices much less useful, as the virtualization layer can't really see which blocks are unused. If the OS's file system layer sends trim commands to the virtual device, as if it is an SSD, and the virtual controller interprets these, then that may solve this, but I don't know of any circumstances where this actually happens, and a wider discussion of that is a matter for elsewhere. We are already getting close to being off topic for the original question, so if this has piqued your interest, some experimentation and/or follow-up questions may be in order.
Warning. I was shocked by how many files PhotoRip could retrieve from my disk, even after wiping. Whether there is more security in filling the free space only one time with 0x00 or 38 times with different Kabbalistic standards is more of an academic discussion. The author of the seminal 1996 paper on shredding wrote himself an epilogue saying that this is obsolete and unnecessary for modern hardware. There is no documented case of data being physically replaced zeros and recovered afterwards. The true fragile link in this procedure is the file system. Some file systems reserve space for special use, and it is not made available as free space. But your data may be there. That includes photos, personal plain text, emails, whatever. I have just Googled reserved plus space plus ext4 and learned that 5% of my home partition was reserved. I guess this is where PhotoRip found so much of my stuff. Conclusion: the shredding method is not the most important, even the multi-pass method still leaves data in place. You can try #tune to fsm0/dev/sdn0 before mounting it. If this will be the root partition after rebooting, make sure run M5 or M1 after unmounting it. But still, one way or another, there may be some space left. The only truly safe way is to wipe the whole partition, create a file system again, and then restore your files from a backup. Fast way, recommended. Run from a directory on the file system you want to wipe. Notes: the purpose of the small file is to reduce the time when free space is completely zero. The purpose of sync is to make sure the data is actually written. This should be good enough for most people. Slow way, paranoid. There is no documented case of data being recovered after the above cleaning. It would be expensive and resource demanding, if possible at all. Yet, if you have a reason to think that secret agencies would spend a lot of resources to recover your files, this should be enough. It takes much longer time. Warning. If you have chosen the paranoid way, after this you would still want to do the fast wipe, and that's not paranoia. The presence of purely random data is easy and cheap to detect, and raises the suspicion that it is actually encrypted data. You may die under torture for not revealing the decryption key. Very slow way, crazy paranoid. Even the author of the seminal 1996 paper on shredding wrote an epilogue saying that this is obsolete and unnecessary for modern hardware. But if yet you have a lot of free time and you don't mind wasting your disk with a lot of overwriting, there it goes. Note: this is essentially equivalent to using the secure delete tool. Before the edit, this post was a rewrite of David Spilett's. The cat command produces an error message, but I can't write comments on other people's posts.
There is zero free utility, at least in Ubuntu. This URL. Also check this link about Zero Free, keeping file system images sparse. It is from its author, Ron Yorston, 9th of August 2012.
If you want to support the channel, please consider subscribing.